Somewhere in the world, right now, someone is dying. Not in an accident, not violently, just quietly, in a hospital bed, in a house, in their sleep. And for the first time in history, scientists can actually tell you what is happening inside that person's head, minute by minute as it happens. What they've found is stranger than anything in a movie. Because dying, it turns out, is not an event. It's a process. A long, slow, surprisingly active process. And it starts long before you'd think. Let's begin 2 hours before clinical death. At this point, most people are still conscious, still themselves, but the body has already started making decisions without asking permission. Blood is quietly redirected away from the skin and the hands and the feet toward the organs that matter most. This is why dying people often feel cold, why their fingertips lose color first. The body is triaging itself, keeping the brain and heart supplied for as long as possible, sacrificing everything else. Around 20 minutes before the heart stops, breathing changes. It slows, then speeds up, then slows again in an irregular rhythm. Doctors call Cheney-Stokes breathing. It sounds alarming to anyone listening, but researchers believe it isn't distressing to the person experiencing it. The brain, they think, has already begun releasing itself from the urgency of oxygen demand. Now the heart stops. Second 0. For the next 20 seconds, nothing changes on the outside, but inside the skull, something is happening that took researchers decades to detect. In 2013, a team led by neuroscientist Jimo Borjigin ran an experiment on rats that would later reshape how we think about human dying. As the animals' hearts stopped, their brains didn't go quiet. They produced a massive synchronized burst of high-frequency signals, more organized than anything seen during normal waking life. The brain, starved of oxygen, appeared to be doing the opposite of shutting down. That finding raised an obvious question. Does the same thing happen in humans? A decade of research since has suggested yes, at least in some cases, and it happens to line up with something doctors have been hearing from survivors for years. Dr. Bruce Grayson, a psychiatrist who has spent over 40 years at the University of Virginia collecting accounts from people revived after cardiac arrest, has documented thousands of cases with a strange consistency. People describe a sudden and total absence of fear. Many describe their thinking as clearer and faster than at any other point in their lives. Not foggy or slow, but sharper. Time, several report, stops behaving normally. A moment can feel like it stretches for what should be an impossible length. One recurring account involves sound. Not silence, but a specific tone or hum, described independently by patients with no contact with each other, right before other sensations begin. Nobody has explained why. Some researchers suspect it's the last function of the auditory cortex misfiring as it loses its supply of oxygen. Others think it may simply be the sound of blood no longer moving. Back to the body. At 60 seconds, cells throughout the body have switched from burning oxygen to a backup metabolic pathway that doesn't need it. This works, but it's inefficient and it produces acid as a byproduct. That acid is the reason muscles go slack, the reason the jaw relaxes, the reason a dying person's face changes so quickly and so visibly. It isn't peaceful looking by accident, it's chemistry. At the 2-minute mark, we reach what doctors call the point of reversibility. This is the window CPR and defibrillators are built for. Brain cells can typically survive without oxygen for 4 to 6 minutes before damage becomes permanent, though therapeutic cooling techniques used in some hospitals have pushed that window further by slowing the cell's metabolic demands. Inside this window, a person is not alive in the way we normally define it, but they are not gone either. They exist in something researchers have started calling a third state, neither fully alive nor biologically dead. A gray zone medicine is only starting to understand. If nothing intervenes, by the 4-minute mark, the damage stops being reversible. Neurons begin a process called excitotoxicity, flooding themselves with more signaling chemicals than they can handle, effectively short-circuiting from the inside. This is the true point of no return. Not the moment the heart stopped, but minutes later, quietly, without anyone in the room able to tell the difference. Here's where the story usually ends in most explainers, but the body's story doesn't stop at brain death. It keeps changing for hours. Within 20 minutes, in a process called lever mortis, blood that is no longer being pumped begins to settle downward, pulled by simple gravity, pooling in whichever parts of the body are lowest. This is how investigators can tell if a body has been moved after death. The pooled blood pattern won't match the position it's found in. Between 2 and 6 hours, rigor mortis sets in. Muscles, deprived of the energy molecule that normally lets them relax, lock into place. It isn't the muscles seizing up as some final act. It is the literal absence of the fuel required to let go. The body becomes stiff, not because it is holding on, but because chemically, it no longer can release. And somewhere in this window, temperature begins its slow decline toward the temperature of the surrounding room, a predictable rate forensic scientists have used for over a century to estimate time of death within an hour or two. None of this is what most people imagine when they picture dying. We picture an instant, a single moment where you are and then you aren't. But the actual science describes something closer to a slow tide going out, one system letting go after another over minutes and then hours, with the brain, oddly, the very last thing to fully release its grip. There's a detail from Dr. Samparnia's research at NYU that tends to stay with people. In interviews with survivors of cardiac arrest, he's found that almost none of them come back afraid of dying again. Whatever it is they experience in that gray zone, fear wasn't part of it. What they mostly report afterward is a shift in priorities. Less interest in status, more interest in the people already in their lives. Less urgency about the future, more attention to the day actually in front of them. Maybe that's the real finding buried in all of this research. Not what happens after the heart stops, but what it reveals about what mattered before it ever did.